Hi, my name is Daachayani Veerapandian, CE200140 from Group 3. Before I begin, let me introduce my group members. My group members are Aiman Fikrie, bin Shafie, DE190143. Next is Amirul Akmal, bin Zuhaili, DE190203. And Mohamad Afiq Afandi, bin Mohamad Khusrin, DE190109. And myself, Daachayani Veerapandian, CE200140. Today, my group members and I would like to present about DC fan, about our project based on solar DC fan with DC to DC boost converter. So, I'll be presenting about introduction and flowchart. So, let's begin. About introduction, I would like to intro a little about DC to DC converter and a solar DC fan. So DC to DC converter is an electrical circuit or electromechanical device that changes the voltage level of DC source. The types of DC converters are step up or also called as boost converter. Next is step down or also called as buck converter and buck and boost converter. About solar DC fan is a mechanical fan with a DC motor and solar panels that charge fan using solar energy. Solar DC fans are widely regarded to be more efficient than other motors due to low power consumption, and it also creates less noise when it functions. So in this project, my group members and I, we use solar DC fan 24 volt, and the type of DC converter we choose is boost converter circuit. So about the flow chart. First, we determine the requirement components needed in this project. Next, we calculate the specification of DC to DC boost converter, and we design the block diagram in MATLAB Simulink. And then we set up the MPPT controller with function command. If there's error occurs, we will go back to set up the MPPT controller, and if there's no error occurs, the simulation is success. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Afandi bin Mohamad Khusrin. My matric number is DE190109. In this video, I will explain about the design and calculation analysis for our project. Okay, first for design analysis, our group used the three main components, which is a PV array, MPPT controller, and the DC-DC boost converter. For the PV array, we must set the number of cells per module is 10. The max power is 70.68 watt, and the voltage at max power point is 16.67 volt. Next is a MPPT controller. The duty cycle must be set to make sure the greatest power can be delivered during the power transfer process. The type of controller that used in the MPPT is a perturb and observe (PNO). The next one is a DC-DC boost converter. The function is to convert the DC input to the high DC input. The type of switch that used in the boost converter is a IGBT switch. To set the DC-DC boost converter, we need to do a calculation. For the calculation analysis, the parameter that need to be calculated in the boost converter is the R, L, D, and C value. So based on the parameter given below, we can find the value for the D, R, L, and C. So based on this equation, we can put the value for Vs and Vo, and the value obtained for the duty cycle is 0.31. Next is a resistor. So based on this equation, we can substitute the Vo and the PR. So the value obtained for the R is the 8.15 ohm. The next one is inductor. To find the inductor value, we need to find the L minimum first. So based on this equation, we must substitute the duty cycle value, resistor, and the frequency. So after we substitute the value based on the table, so we find out the value for L minimum is 15.04 microhenry. And then to find the L value, we need to multiply it by the 1.25. So the value for the L is 18.8 microhenry. The last one is a capacitor. So based on the capacitor formula here, we can substitute the D RF value from the table here. So the final value for the capacitor is 95.09 microfarads. That's all from me. I will pass the next present to my friends.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul bin Shafie. My merchant number is DE100143. So today I'm going to present for the circuit design of the project in the MATLAB Zuhaili. So for the circuit design, it will consist of a PV array, DC to DC boost converter, and also the MATLAB function which is for the calculation of the duty cycle. For the PV array, we use a PV array module Sunlight 71, which is the maximum power 70.68. The maximum voltage is 16.67 and the current at maximum is 4.24. This means when the irradiance is 1000 and the temperature is 25, the value of voltage and current will produce at its maximum. So for the resistor, inductor, capacitor, and resistor, the value has been set as the calculation analysis. And then after that, for the MATLAB function, this is the coding for the duty cycle. So it will do the calculation here. And then after we run the simulation, it can be observed that the voltage has been stepped up from 16.55 volt to 23.6 volt. I think that's all for my part. Thank you.
Assalamualaikum. My name is Amirul bin Zuhaili and my matrix number is DE100203. So I will continue with the simulation part and I will explain the waveform of the input and output of the circuit. Right, so firstly, we have two scopes, which is the first scope is for the input signal that came out from the PV array, and then the second scope is for the output signal that taken directly from the load. So without wasting time, let's have a look on the first graph. Right, sorry, the first scope. So this is how the input waveform looks like, right? So we observe three parameters, which is power, current, and also voltage, right? And then here we can see that at some period there are resonance occur, right? Which means that it swing a little higher than the normal period, the waveform at the normal period, right? And then it does not occur at the power waveform, but also at the current and voltage waveform as well, right? And then it is synchronized, which means that when the resonance occur at this period, right, on the power waveform, it will also affect at the current and voltage waveform. In our simulation, the input power is 70.68, right? So here at the amplitude of the reading, we can see that it is between 80 and 60. So we know that it is 70.70, right? But the oscillation or the fluctuation that occur in this waveform, it will give a different decimal point, right? It just affect the decimal point, right? And then our input current is 4.261, right? So in the simulation, we display it using a display block. So we get 4.261, and then our input voltage, we set it to 16, but in the simulation we get 16.55, right? So let's have a look on the second scope, right? So this is the output waveform, right? So the thing that I need to tell is we can see that the wavelength is a bit short, is very short, right? Right, so this is because of the switching frequency that we set, right? We set it to 40 kilohertz, right? So we know that frequency and wavelength is inversely proportional, right? Which means that if we increase the switching frequency, then the wavelength will be short, right? So here, our output power is we can see less than 70, which means we know that there are some losses occur, right? And then for our output current, we get 2.8 something here, right? And we know that we get lower than the input current, which input current we get 4.261, and the output current we get 2.8 something, right? And then here for the voltage out for the output voltage, we get 20 in calculation we get 24, but in this simulation we get 23.6, which is approximate to 24, right? So we are using the DC-DC boost converter, so we want to boost the voltage from 16 to 24. So when we increase the voltage, the current will be decreased, right? So current and voltage, it is the correlation, it is inversely proportional, right? And then if we try to zoom in, we can see ripple, right? You can see ripple, and this kind of ripple, we know that we can reduce the ripple if we reduce the capacitance value in the circuit, right? So we need to adjust the capacitance, but in this simulation we use our capacitance value is 88.09 microfarad, right? So that's all from me.
Last but not least, it can be concluded that the DC boost converter can step up the voltage, the input voltage to a certain value of the output voltage. And in this project, PV system we use as the supply because PV system can convert the heat energy from the sun to electrical energy, which is alternative way instead of battery. And from the simulation, it can be monitored that the input voltage has been stepped up from 16.67 volt to 23.6 volt to supply the load, which is the DC fan, which is it will connect the DC fan to the parallel with the resistor. I think that's all for my part. Thank you.